It is my great pleasure today to receive Neil Theise. He's an MD, a liver pathologist, an adult stem cell researcher in New York City. He is also professor of pathology and of medicine at NYU Grossman School of Medicine. What is amazing is also a trained Zen practitioner for about 35 years. He has a Jewish practice and is trained in shamanism. My favorite kind of person, blending left brain and right brain in perfect harmony. Neil, welcome.
Thank you very much, Bruno. Perfect harmony, I don't know. Seesaws, maybe more.
So today we decided to talk about fascia, interstitium with a drop of consciousness and complexity and chaos. It's going to be very interesting. Where do you want to start?
You choose.
Well, let's start.
One thing leads to the other all the time. So
yes. Maybe we start chronologically with your work with liver pathology and the interstitium, the little piece of anatomy you discovered.
Sure. Liver includes the liver and the bile ducts. And some endoscopy colleagues of mine. I used to be at Beth Israel Medical Center down the street from where I am now, and they were my next door neighbors. And they had this interesting new endoscope that they were playing with. And when they put it into the bile duct, they saw something that didn't correlate with anything they understood about the structure of the bile duct. So the point of this scope is that when you inject some fluorescent dye into the blood, it quickly circulates through the body. And there's a lens at the tip of the endoscope that allows it to see 70 microns into the tissue. So that's about 7/100ths of a millimeter into the surface of the tissue. And so they're looking at the microscopy of living tissue, as opposed to what I do when I look at tissue in my microscope. I'm looking at dead tissue that's been sliced thin and put onto a slide.
Dead, dehydrated, dyed.
Dehydrated, fixed, dyed. It goes through all these things. I joke, but it's not that big a joke, that the point of an endoscope like this is to put me out of business. Because if they can see the microscopic structure of normal and diseased tissues with the endoscope, why do they need to pick a piece of tissue and send it to me to look at? Because they can do it in the moment. But when they looked in the bile duct, they saw structures that did not look like anything they recognized. And so they came to me as the liver expert. I must know what the bile ducts look like. It wasn't clear to me what these structures were either. So what they were seeing, 70 microns into the tissue, you're directly into the connective tissue. That's the middle layer, the submucosa of the bile duct. In all the other stretches of the GI tract, you only get down into the mucosal layer, which is the inner surface of the bowel. But in the bile duct, because the mucosal layer is so thin, you're immediately into that middle layer, which we think of as dense connective tissue. So when they looked with the scope into the living tissue, they were finding these large fluid-filled spaces within that layer, separated by dark bands.
How large?
And
How large?
The bands are about 10 to 20 microns across, so 1 to 2/100ths of a millimeter. And these spaces anywhere from 40 to 200 microns across. So 5 to 10 times the size of the band. So they're large fluid-filled spaces. But these cross-connecting black bands, I immediately said, oh, those are capillaries. And they said, no, they can't be capillaries, because then they would be bright and the spaces between them would be dark. This was the reverse. So this was a puzzle. I looked at my slides of bile ducts, and because I get them as part of resection specimens, and I couldn't see anything that correlated with that. And every once in a while, you see there are little cracks in the tissue. And that's always been explained to me, and I've explained to a generation of my students, that collagen is so stiff when you try to cut very thin sections of fixed tissue, it cracks, and that it's an artifact. And we just look past it, we ignore it. In fact, when I show slides to someone who's not used to looking at slides, they'll often say, what are those white spaces? And I don't even see them anymore because they're just cracks and my brain erases them. The fluid had washed out of the spaces, but some of the dye, which is very highly charged molecule, was stuck to whatever these bands are. And what we found is that while the normal structure of this layer of the bile duct looks like dense collagen, in the living tissue, it was actually a web of collagen bundles supporting these now empty spaces. So we thought that this stacked appearance was real and the spaces were artifactual cracks. It turned out the reverse. The dense wall was artifact, and these cracks were remnants of the living spaces, the spaces in the living tissue, and that are filled with fluid. So we thought first, oh, this is something really cool about bile ducts.
So, Neil, that is in the common bile duct, right?
Right.
Yeah.
So at this stage of my career, I only see specimens from the GI tract mostly. So then I was getting normal clinical specimens from stomach, small bowel, large bowel, esophagus, and looked at the submucosa in those tissues and realized I saw all the same cracks. Oh, wait a second. They're not cracks. So this isn't just the bile duct, the wall of the common bile duct. This is the wall of the entire digestive tract. So I was trying to wrap my head around that. And then sometimes I was called on to do general pathology. And this was within a couple of weeks. I got a mastectomy specimen for breast cancer. And a mastectomy specimen always comes with a piece of skin overlying it. And so I had sections of the skin, and there in the dermis of the skin were the same cracks. And we found a place on my body, it turned out to be just right over here, where the scope could get, where the surface of the skin was thin enough that they could get into the dermis. And there was the reticular pattern.
So not the epidermis, just the dermis.
The dermis. What this meant is that it's not only the GI tract, it's also the skin. More importantly, as a way of studying things, this proved that if we see cracks in the collagen on a routine specimen, it means there were spaces that are fluid filled in the living tissue. And once we could see that, we could then study any tissue in the body that I had access to. And because I'm a pathologist in a large pathology department, that means I can study any tissue in the body. So we've had a series of publications now that show that this is a continuous network of spaces that runs through all the connective tissue of the entire body. It is fluid filled. It is filled with a lot of macromolecules, in particular, hyaluronic acid.
You start to publish in 2018, right? That's when you
Yeah,
start.
something like that.
Yeah, I remember those. Now, I sent you something about the lymphatics a while ago, and they had what they call the pre-lymphatic channels, the tissue channels, the pre-lymphatic pathways, and that were known, but that is not the same thing.
Well, so the thing is that, it's been known that lymph derives from the interstitial spaces. That's been known.
So basically what they say is in the embryo, those free fluid channels are going to organize themselves. And if you have a pattern, a lot of fluid in one direction, mesenchyme cells are going to go around these channels and create lymphatic vessels because of the need of the tissue to evacuate this fluid.
So let me back up before we get to this. So why did we talk about this being interstitial? And when we published, there was a lot of frustration, shall we say, about how we published and what we said. Which we own. So a lot of people were like, what do you mean the interstitium is new? We've known about the interstitium for 100 years. We haven't known about this part of the interstitium. So the interstitium historically has only been recognized at 2 levels of scale. There are some cells that are not tightly bound to each other, that have spaces, gaps between them, and those are intercellular interstitial spaces. They are filled with fluid, and hyaluronic acid and other proteoglycans. The second scale of interstitial space are the most important one that people have talked about, which is the space between capillaries running through tissues and the cells that they're supposed to be contributing nutrients to and carrying away their waste. These are 10 to 80 microns across outside of the capillary. So in some organs, tissues sit just on the capillaries, but in most places, actually, there's a little gap. And so when people have studied the interstitium in prior decades, that's the space they're talking about. There is an assumption based on some electron microscopy, some functional studies, that lymph derives from the fluid flowing through those interstitial spaces. But there are diagrams of what those look like, but there are no pictures of what those look like. So there's an assumption here. It turns out that that is not usually the case. There is this much larger size interstitial space that is in continuity with all those other spaces. And the lymphatics interface within this much larger interstitium that we've described that had not been described before. So that's what's new. We are saying that the interstitium was viewed through this little narrow lens, and now we're looking at a whole body lens, and it's actually a very large network. Fluid volume of this network is probably 4 times the size of the cardiovascular system. So it isn't at the microscopic level. And the interface with the lymphatics seems mostly to be at these larger scales, not at these tiny scales.
I have a photo of something. All right, here we go. So this is a picture talking about pre-lymphatic pathways of tissue channels, 0.1 to 10 microns, right? 1987 in the rabbit. So that the pre-lymphatic pathways, that's 0.1 to 10. And this will be the collector lymphatics, 50 micron. They're going to go 200 micron after that. And so this is organized pathway with cells around, and this is tissue pathway, crack in the tissue. And those was assumed here to enter the lymphatic pathways, the valve of the lymphatic pathways. This is for you the small.
Right. It is assumed that it enters, but how does that entry happen?
Well,
we don't have a picture of the entry point.
Well, then you have valves, in inlet valve, they call it sometimes. These are lymphatic capillaries.
Right, the lymphatic capillaries.
And this is the way they look. They are described.
Right, so here you already have a tube.
A junction, yeah. The open junction.
No, not a junction. You have a tube. The endothelial cells.
Lymphatic capillary. With the junction between.
But those original channels, you have no tube.
No, that's the idea.
So where does one meet the other? You haven't shown me that picture.
The junction here, you enter through those junction in the tube, the open junction. This is an oak leaf cell with a little opening there, and that's where the water. And they said there's a negative, there's a suction for 2 reasons entering through those openings, and those openings open and close. So schematically, it will look like this: they open and they close.
Yeah, that's a schematic.
Yeah, but this is
you haven't shown me, right? So
microscope.
You're showing me the open mouth.
Yeah.
But you're not showing me where that structure meets that structure.
But you are surrounded by interstitial fluid here, and you have an opening. And so if you just assume it's going to enter.
Yeah, but you're not really
you need to
being specific yet. So let me show you my picture, and I'll show you what you're missing. So this is from our paper from 2 years ago, and it's been reproduced in a paper and a chapter that just came out in a book on the mesentery. This is the surface layer of the colon, so the mucosal layer of the colon. When we stain for hyaluronic acid, colored brown, that the spaces between the glands are filled with hyaluronic acid. So this is that second level interstitial space. You can see there are gaps in the wall between the myocytes. And here there's hyaluronic acid filling that space. Down into the spaces between the cracks, you see these little white things. All these little white spaces are the residua of the larger spaces that you see in the living tissue. This is fixed tissue, and it's filled with hyaluronic acid, which then is continuous down through the muscularis propria, between myocytes, but also along vascular and nerve bundles that come into the wall of the bowel. And you see it come down here into the mesenteric fascia. So now what we have is a continuous space between collagen fibrils and collagen bundles from the surface of the bowel at the mucosal surface all the way down into the mesenteric fascia. So a space that's spanning across organ boundaries and across tissue boundaries with no interruption. So that's something new that we have shown here, because without these larger spaces, it was just assumed that all these interstitial spaces around capillaries were all just local things within the tissue. But here it's one huge space that spans the tissues and crosses organs. This is a close-up of some of the mesenteric fascia. These white collagen bundles here are about 10 to 20 or 30 microns across. This magenta stain here is vascular endothelial cell, CD34. So these are the capillaries. So however you cut a capillary, you may see a circle, or you may see an oval, or you may see sort of this squashed, elongated thing. The capillary has hyaluronic acid around it. This is the interstitial space around the capillary. And it has little collagen fibrils there and hyaluronic acid alternating. But then those spaces are continuous with the larger spaces of the larger scale interstitium that we're describing. And over here, we've actually gotten lucky and gotten a perfect transection through the open mouth of the lymphatic. There's no way this is an artifact, because with a closed tube, there's no such thing as an open mouth artifact. Here we have to be seeing the actual stoma, the actual mouth of the lymphatics, and its interface is at the fluid flowing through these larger scale spaces. So this is the first picture that I'm aware of in human tissue of the actual relationship between the capillaries, the interstitial spaces, and the lymphatics, all in one image. It's not an artifact. It's not an electron microscopic picture that's really close in, just right over here, and we're extrapolating what we think the context is. This is actually showing the real context. And the vast majority of lymphatics and tissues are related that I've examined so far, and we've looked at breast, lung, colon, skin, subcutaneous soft tissue, the GYN tract. Almost all of the lymphatics have this relationship with the interstitium and the capillary. It's at the larger scales.
What do you use to specifically dye the lymphatic there? Do you remember?
Oh, right. Thank you. I'm sorry I didn't say that. This is using podoplanin, D240. I wanted to use Live1, which stands for LYVE1, lymphatic vascular endothelial marker 1. I wanted to use that because that actually turns out to be a hyaluronic acid receptor. The problem is that we couldn't find a way to make that staining work with CD34 in the same tissue. So we use the podoplanin. So this is a triple stain, which itself is pretty unusual, frankly.
Yeah, it's great. So you could see that basically at that level of the tissue, wherever you have blood vessel, you're going to have a lymphatic vessel.
It's not uniformly distributed. I haven't gotten full pictures of this, so I can't show you. But for example, in human skin, you have some lymphatics in the papillary dermis near the top, which is the equivalent of this pericapillary stuff. But they're not interwoven the way the diagrams are written. And then you have far more lymphatic drainage down below the dermis, at the lower margin of the dermis and into the subcutaneous tissue. So most of the dermis had very few lymphatics in it.
Compared to the blood tissue.
Yeah.
Below, but not in the hypodermis. You mean still in the dermis? You're still in the dermis.
I mean, in the dermis. It's not evenly distributed throughout. In the submucosa of the bowel, the lymphatics seem to be more evenly distributed through the submucosa. In the dermis, it seems more at the top and at the bottom.
Could you say you have two layers of more dense vascularization of the lymphatics? Because they describe that sometimes 2 layers of lymph capillary, and you have pre-collector or collector in between.
Maybe, and this is the sort of thing we've just started to, we just developed this stain, which allows us to do all this. So we've published this in the mesenteric paper. We haven't published it elsewhere. I'm starting to prepare this in all those other organs. I've seen the images and we're starting to write the papers, but we're just starting to do the analysis here. So I can't say much more than what I've said.
In the dermis, in comparison, the blood circulation would be much more uniform, and you don't have 2 layers, something like that. You would have like all through the whole cut, you would have the same amount of blood capillaries, blood vessels.
Yeah.
So what?
Now,
go ahead.
I'll show you something else that's very exciting. These blue nuclei here are all cancer cells, and they just line up, parading through the tissue, not damaging the tissue, just parading through it. And it's never been understood how they know to line up and how they make it through without showing much more obvious damage. But here it's clear they're marching through these spaces. They're not injuring the tissue. They're actually just marching through these hyaluronic acid-filled spaces. And we were lucky in a couple of places where we actually got the cells going right into a lymphatic. So this is one of the ways that breast cancer gets into the lymphatics to get to the lymph nodes. It doesn't even require direct tissue destruction and invasion. They can just march through these interstitial spaces right up into the lymphatics.
So do you have stem cells in those spaces? Right?
I don't think so.
You don't think so?
And the reason I say that is that most stem cells perform as stem cells within specific tissue locations, called the stem cell niche. And those are very highly structured spaces. So most tissue stem cells are not wandering around the body. Now, a lot of my work showed that many stem cells can wander around the body. So stem cells from the bone marrow can enter the liver and become liver cells, can enter the lung, become lung cells, et cetera, et cetera. And that happens. But they aren't going through these spaces. They're probably coming directly through the capillaries into the smaller interstitial spaces, then they colonize that area directly. So I think that's what's going on with stem cells.
You have smaller interstitial spaces, and then you have this big freeway in these larger interstitial spaces.
There are very few cells trafficking through these spaces in normal, healthy tissue. They're fairly empty. There are three kinds of cells that we see. First, there are the lining cells. These are a kind of fibroblast, and Carlos Stecco in some kinds of fascia will call them fasciocytes. Some people will call them telocytes. We call them interstitial lining cells. Some people just call them fibroblasts. They're probably not all the same cell type, but there's a good chance we believe that they're all part of a lineage. So that's one cell collection of cell types, these flat cells that line the collagen bundles, fasciocytes, fibroblasts, telocytes, lining cells, whatever. Now, the other two main cells, there are very few lymphocytes here in normal tissue. What you see are mast cells and macrophages.
Macrophage, you can assume, yeah.
Right. We've used the macrophages a lot because when you put tattoo pigment in the skin or with an endoscope in the submucosa of the GI tract where you resected a malignant tumor, you see the pigment within these spaces, and you see macrophages chewing up that pigment, and you see how those macrophages migrate from that space to the lymph node,
exactly,
proving again the lymphatic connection. It's from this area where the structures are bigger. So it makes sense. This space is very closely associated with the outside world. In the GI tract, the center of the bowel, which is the outside of your body, really, right? Because our body is like a donut. The whole is your GI tract. You'd want to have macrophages there picking up debris. It makes sense. The other cell that you have there are mast cells, which are a kind of white blood cell. They're involved in hypersensitivity reactions, allergic type reactions. A fair amount is known about them, but it's a strange little cell type, and there aren't a lot of people in the world studying them compared to the people who study lymphocytes, for example. So there's less known. The way there's less known about the liver, I think, than there is, for example, about the skin, because way fewer people in the world study liver. So these mast cells are lining this space. And again, that makes sense that you'd want some sort of representative of the immune system between the inside and the outside. In the colon, the only separation between the inside of your GI tract and the interstitial space is that single lining cell along the top, right? It's one cell apart, inside versus outside. If I show you another picture.
But you're saying there's very little of those immune cells. They are not.
Right. So so there are the macrophages and there are mast cells. Now, one of the interesting things, there are diseases that involve mast cell dysfunction, and they are particularly common in people who have a collagen defect called Ehlers-Danlos syndrome. I happen to have that, so I can do weird things with my fingers like that. This defect is a defect in type 3 collagen. It's very specific. And yet people with this have weird mast cell dysfunctions. I don't, at least not yet. But this is where mast cells hang out. This is the mast cell niche. So there's some interesting crosstalk between mast cells and the extracellular matrix in the form of type 3 collagen that modulates mast cell functioning. So again, there's this turns out to not just be this dead stuff between the living cells of the body. This is dynamic, physiologically important tissue that has all sorts of functions and interactions between everything. It's the interstitium, by definition. It's the stuff between everything. And so in many ways, it's the communication pathway between everything. And it's a part of how every piece of the body modulates every other piece of the body.
And you know what? When we touch it with our hands, this space has an enormous amount of consciousness. It's deeper, it's like a vortex. Sometimes I say it's a connection between material and immaterial spaces. It's an amazing space. It's deeper than what you feel in the lymphatic vessels. It's even deeper than you have in cerebrospinal fluid, which is a very high, noble quality fluid. This interstitial fluid space, for me, is one of the deepest space full of consciousness that you can palpate. So it's a very, very important, and sometimes I say it's not that we have cells with a little bit of fluid around it. It seems that we have fluid that carry and nurture and sustain the cells. So that's a very old medium that receive those cells, but are like the mother, nurturing these children. So it's a very, very important space, and that's can give us a bridge to consciousness and chaos theory, if you want. So that's something that's subjective experience, but when we feel it, it's an amazing space. Even though you have a little bit of fluid, a little bit of cells, you describe that, but when you touch it, and it's as a living system, it's a system that has a lot of information. And
I've had enough experience in my life, and very, very few experiences, but vivid enough to tell me that it is possible to sense subtleties like this that are not things of the material world per se. And you mentioned I have a shamanic practice, and I suppose maybe the most important thing that has taught me, other than my intuitions are real and I should pay attention to them, is that there are non-material aspects to existence that are perceivable. I've learned to be careful about taking in reports from skilled practitioners about these things. And the best example of this is a long-term yoga teacher of mine who's also a rolfer. With my Ehlers-Danlos, I've needed a lot of attention, and she has given me a lot of attention. She would be messing around in my body. Number one, I would have experiences where she would touch something and I would have flares of emotions or memories that were recovered and stuff like that. So there's that sort of thing. But she would always tell me how my fascia was filled with fluid. And I would say, no, it's not. I've seen it on a slide. There's no fluid. And she'd say, yes, there is. And I'd say, no, there isn't. I've seen it. What are you talking about? In the original paper, there's fascia with these spaces. And the reason that picture is in there is because of Debbie, because she was right. And she could feel that fluid. even though my training with what I could see under the real tissue said it's not there, but it's because I didn't know how to look. So I've learned to appreciate intuitions like this, that they have meaning, that could point me in directions for what I'm seeing in my research. At the same time, I've also learned to hold it very lightly. So what you've described to me is you're putting into words this experience that is not verbal. And so you're using words like vortex and mother and information, all of which are vivid ways of describing what the experience is, but they are not precise. They're metaphors. And here I just hold it as an open space. I'm trying to let your experiences, as they filter through your words, not just you, but everybody I'm meeting through this adventure. So I'm always on the lookout for the things where what I'm seeing meet what you're describing. One area where I think I have confidence that we're going to find something important is that it turns out that collagen bundles, collagen fibers, when you stack them up thick enough, how thick? This thick, they become piezo crystals, which means that a piezo crystal is any material that if you bend it or move it, it generates electrical current. Or in the reverse, if you shoot electrical current through it, it moves. So with an ultrasound machine, the way it generates these waves, these ultrasonic waves, is that you have a piezo crystal, an electrical current is passed through the crystal, it starts to vibrate that way, creating these sound waves. It turns out that this collagen is piezo. And these tissues are intermittently or continually moving in every tissue of the body. Becky has done some preliminary measurements which show that the electrical activity produced by that movement is sufficient to have an influence on cell behavior.
Yes, make a no transaction. So first question is, when she told you you have a lot of fluid around your fascia, before your articles, I mean, connective tissue, glycosaminoglycan, fluid of fluid, I mean, you knew there's fluid around in the connective tissue around. So why would it be amazing to say that you have a little bit more extra fluid in your extracellular compartment? You know, to see an edema, you need about 30% more fluid into your extracellular compartment. If you have 15% more than usual, you don't have an edema, but you have something a little bit different. And she could have felt something in your connective tissue that was a little bit extra fluid compared to other people she touched. You couldn't imagine that she was feeling the extracellular compartment and feeling a little bit of extra fluid there?
She didn't say I had too much fluid. She says your fascia has fluid in it. I said, no, it didn't.
But when the connective tissue has fluid in it?
No, but by allopathic medical microanatomical descriptions, no, it does not. Now, the fascia world has been saying for 40 years it has fluid in it. Osteopaths have been saying there's fluid in it.
But
you can't see it. No one has shown it in the tissue using the microscope, basically until we came along.
But I mean, I saw picture with glycosaminoglycan, trapped fluid, free fluid, trapped fluid, and fluid into the vesicle. So I mean, that's
right. So go show me those pictures, and I'll make you a bet you're seeing pericapillary interstitium.
Right, but still, it was known. I mean, in med school, they tell me there's, the extracellular fluid. So why wouldn't you have a little bit more extracellular fluid?
But it isn't a little more extracellular fluid. We're talking about tiny amounts of extracellular fluid around the capillaries,
right,
that are local, discrete structures in their own local locations in each tissue. What we're talking about is a vast connective tissue network that spans all tissues.
Right.
Now, one of the problems, there's lots of things hiding in plain sight. So estimates of the amount of interstitial fluid in the body are fairly consistent over the last 50 years. It's about 4 times the size of the cardiovascular system.
Right.
But the cardiovascular system is huge compared to these tiny capillary, pericapillary spaces. How do all these tiny, 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 tiny spaces add up to that much fluid? Because they're missing 95% of the volume anatomically.
Yeah,
so we're not saying there's more fluid than there used to be. We're saying we now know the anatomy of that space. Your community was very responsive to our work.
Sure.
The same year I came to the Berlin Fascia Congress where we met, to me, this is not only a physical interstitium, but it seems by the way people are responding to it, that it can be a cultural interstitium that allows people from different cultures of health and healing to explain to each other what they've been talking about.
Mm-hmm.
Never in my life did I have any urgency to explain how my healer friend, yoga teacher, told me there was fluid in fascia. It turned out 5 years later that suddenly I could go, oh my God, I think I figured out where the fluid goes. Where the sort of stuff you're talking about now, yes, I have had experiences that to me say that there are non-material aspects to the world. And what I mean by non-material, and my shamanic teachers tell me that the non-material beings perceive us as though we're the dream and they are solid because they can perceive their material. So when we talk about the multidimensionality of string theory, are strings the answer or not? No one knows.
We don't know.
Open hypothesis, multi-dimensions, entirely possible, whatever that means. I'm much more interested in your reporting to me the things you can be aware of that I can't see, that because I either lack the talent, the sensitivity, or my collagen is funny because of my Ehlers-Danlos. Maybe that's part of why I can't do it. Or I just haven't spent enough time.
A lot of Ehlers-Danlos are very psychic because their structure is not so stiff. And I know extremely sensitive. There's different type of
Right. I'm the rigid kind. So if you ever watch me walk down the street, you'll see I'm very rigid. But the thing is, I'm not so interested in locating your skills and abilities and perceptions in multidimensionality and string theory or multiverse or whatever. I'm more interested in what are you experiencing?
Yes. It's just
and if something in the scientific world meaningfully connects with that, that's very exciting. What terms do we use for this stuff? Is it fascia or is it interstitium? And when I write about this stuff, it's hard to write about because is it fascia or is it interstitium? If I don't want to use the word fascia for one reason or another, I still have to say, is it the collagen or is it the spaces between the collagen?
Right. Now,
and they're not really spaces because they're filled. So do I mean the collagen that's stiff versus the hyaluronic acid filled, which is more fluid and less viscous, or the fluid that flows through it, which is even less viscous?
But historically, Neil, I think 1620 or something like that, we talk about the fascia as a solid structure, mesodermic. And slowly, they extended from mesoderm a little bit more ectodermic origin with the neural crest and at the fluid fascia, because they're also the same origin. And then now they even talk about, Bruno Bordoni especially talk about holographic fascia with all the different photonic.
So I'm just interested in finding a way to communicate what we're talking about.
Yes.
And at this point, there is no defined, fully universally accepted terminology. But to me, one of the interesting things about this is the reason we talked about interstitium is because we were injecting a dye which showed us the fluid compartment. Whereas people who talk about fascia, that derives from dissection of human bodies, where you see this connective tissue layer between things called the fascia. Now, whether you follow the allopathic model, where that's really only the musculoskeletal fascia, or the intermediate view, which is all fiber connective tissue of the body, with the exception of the submucosia, the viscera, and the dermis. If you look at Carla Stecco's diagrams in her book, The dermis is excluded. And she and I are having an ongoing conversation about this. And then you talk to John Sharkey and he says, well, bone is simply mineralized fascia. Carla will just go, you know. So we all have different ideas, and we're not going to come to an easy, rapid agreement on this. But to me, what's interesting is that we saw the spaces, the interstitium, because we were coming in by fluid, and other people saw the connective tissue, the fascia, because they were coming in by the mechanical aspects. Those are complementary to each other. They are not separate. The mechanical aspects of fascia are the way they are because they alternate with this fluid viscous space in between.
Right.
The flow of these fluid-filled spaces are guided by the stiffer structure of the collagen.
Right.
So these are completely interpenetrating, co-creating pieces of a whole. It isn't interstitium. It isn't fascia.
Why it is not interstitium? Because I thought the definition was to the interstice, the spaces between the more solid structure around it. Even though it's still a bit solid, it's still the space between the more solid structure around it, more stiff structure.
But many people in your community will say that's just fascia. Oh, many.
Again, historically,
many.
it was, the fascia as, in Latin, those big bands of solid tissue.
No. There's a whole bunch of people out there in fascia world, many of whom are going to be listening to this tape, will say otherwise.
It's called fluid fascia. So we define that as
no, only by some people. But no, so there's no agreement on this.
So why it's not interstitium? Why it would not be interstitium?
Because they call it fascia.
Oh,
there's no why.
There's part of the fascia. It's a part of the fascia called the interstitium. All right. It's a sub. Okay, I know what you mean. But I don't think that's a big problem.
The point is that what I'm trying to make is that these two things are in complementarity to each other.
Right.
The thing itself in living tissue does not think of itself as fascia or interstitium,
right,
as stiff or as fluid. It simply manifests what it is, all aspects at the same time. Now, we as humans, interacting therapeutically with our hands and fingers, or with electrical current, or in our imaginations, or experimentally through the fluid or with a knife, we are choosing ways to view it that only reveal certain things. So my yoga teacher, using her fingers, perceived the fluid, and that was her focus. My eye, with the scalpel making slides, perceived the collagen. Both of us were ignoring the other half. And this is where we get into the complexity theory stuff that I've been writing about. Complexity theory talks about how interacting individual parts of a whole will self-organize into larger scale structures that nothing planned, they just arise. It's called emergence. And so ants self-organize into a colony, humans self-organize into a city or a culture, cells self-organize into bodies. What you see depends on the scale of observation. So if from a distance I look at an ant colony, I see this dark shape on the ground. It may be moving, but it looks like a solid thing. I go in closer and I see, oh, it's not a dark thing, it's ants. If I go into the microscopic level to look at the ant disappears. There's no ant there, it's just cells self-organizing. Same thing with our bodies. At this level of scale, you're you, I'm me, and we're these things. But at the cellular level, you've already filled your room with stuff you shed from your skin, bacteria that are your microbiome and your dead skin cells, and I've done the same here. And if we could shake hands through the screen, part of you would leave with me and part of me would leave with you. So at the cellular level, our boundaries are not here. We cease to be things. We turn into communities of cells. Cells are nothing more than the communities of self-organizing molecules. Molecules are just self-organizing atoms. Atoms are just self-organizing subatomic particles. And it's not an infinite regress to smaller and smaller. Quantum physicists will disagree on what the tiniest things are, strings versus other stuff. But what they are in agreement of is that there is a smallest scale. It's called the Planck scale, and a smallest unit of time. Space-time is not smooth, as Einstein described it. This is the problem between relativity and quantum physics. There are smallest things, and those just emerge out of what?
Foam.
We don't know. And that's called the quantum foam.
The foam, yeah.
So there is no scale in the universe that you can't view from different perspectives, where it is either a thing or a phenomenon arising from smaller things. And anytime you make an intellectual or a physical engagement with the world, you're selecting in that moment how you're going to experience the world as things or process. So when you are bringing your hands to someone's body, someone traditionally trained in my practice of medicine would say, well, it's all about the mechanics of what you're doing. You're stretching the tissue or you're moving the tissue. And I would reduce it to that, but I would be missing the part where your quantum level body is engaging the quantum level body of the person with whom you're working. And at that level of scale, the boundaries aren't my skin versus your skin. The boundaries are everything around us. There is no practitioner and client. There's just one single living system that is adjusting within itself.
Beautiful.
So to me, this issue of complementarity, it allows us to see and exist in all these different perspectives and modalities. And many of the places in contemporary science, or for that matter, other, other cultures of health and healing, as I like to say, that are resistant to the scientific, the Western science-y kind of thing. No view has the whole thing. No view can have the whole thing, because the structure of existence is complementarities.
Right. When we work on a body, we switch scale very often, going from the laws of a microscopic tissue, I go in an organ, but then maybe I'm going to go on a cellular level, and I'm using different laws and different, and maybe I'm going very small into a cellular level, and maybe I'm feeling like, wow, there's something about too much light, not enough light. Biophoton, biophonon, oscillation. You can change scale constantly. I'm trying to go to the Planck scale, 10
to the minus 37 meters.
35. I've heard 35.
Something like that. I can never remember. I always have to look it up. It's a big number. Well, it's a tiny number.
And 10 minus 41 second.
Yeah.
It's just crazy small, but that is I think that is the dialogue of the universe to us at that level. That's the bottom dialogue, informing us, giving us information, and maybe forming us.
But even there, in the way, and it leads to paradoxical stuff that language cannot contain. Right. The universe can't inform us because we are in fact the universe.
Yes.
Saying the universe informs us. I mean, you're trying to get at it that it informs us because we are of the universe. We don't exist inside the universe like it's a box.
Right. Self-referential. I mean, it's just informing itself. And so conscious universe, the only question I have for you, do you feel there is conscious evolution because the level of complexity of change increase constantly? Is there a conscious evolution through that co-conscious universe?
So first off, terminology. In writing my book, which I have to mention, Notes on Complexity, it comes out in May, which is about all this stuff. Panpsychism, as I've finally come to understand it, I used to be a panpsychist, and panpsychism says that consciousness is inherent in the universe, but it's not created by the brain. It's inherent in either cells or molecules or subatomic particles or something.
You have the emergentist panpsychist.
Right. But idealism is that consciousness is primary.
Yes.
And space-time and everything in it comes out of consciousness.
Right.
And that's how I locate myself now.
Idealism is not part of the panpsychism. It's a monism idealism, like Plato used to be.
Right. Yeah, it's the Platonic system, basically. Right. Plato, Spinoza, probably Leibniz, whether he admitted it or not, Schopenhauer, Kant, etc. All I know is that I entered Zen practice because I wanted to connect with something beyond me. that I have finally come to understand that there is no beyond me, and there's nothing to experience other than what I'm already experiencing, except I'm not usually aware that I'm experiencing. Just sitting in meditation or looking at my slides or having this conversation with you, I'm an expression of the universe as it's evolving within itself. My bias is to say the universe is not trying to become something. It doesn't need to become something. It is, capital I. But it is always changing. It's a process, it's not a thing. Things become other things. Process is just process. So to me, the consciousness of the universe expressing itself in this material existence is the universe being able to experience itself. We're just sense organs for the universe.
Beautiful. Neil, I know you are really busy. It was such a pleasure to talk with you. I think we could have spent all day.
Keep going.
Forever. Be out of time, is perfect. So, well, maybe we'll do another interview one day,
Sure.
and after your book is out or something like this, or maybe we'll meet in person again very soon.
Yeah,